Guys, we're back for the second half. We finished this stupid launch controller. I should be drawing this out on a piece of paper, but this is the outlet. I wasn't thinking in advance. The neutral is always the big side of the plug, and the live is the small tank of the plug. I didn't have to break this tank, but since I did, I simply made a bridge wire with two open spade connectors. I connected that. This maintains the continuity between here and here. Remember, this power in down here, power out up here. So I'm just connecting these two. The ground is already covered. I think what I'm going to do is find some green wire and maybe just kind of hook that up to this guy here, and just it means I have to cut a 3-wire extension cord. That's going to add to the length of the video. I kind of don't want to do that. Let me just put the ground wire in on my own. But here we go, right next to the on-off switch. The only thing this on-off switch is doing is interrupting the circuit. That's where this and this will be connected with the switch in this position, and I'll connect this and this. So power in here, these two guys connected, power in here, power come out here, go to the igniter, the rocket's motor, you'll be able to launch the rocket. All this is an interrupter switch. This is a very, very basic Drew box circuit. Of course, you need a good old-fashioned healthy motorcycle battery, 12 volt, 6 cells and 2 souls, 2 volts a cell, anything from 100 amps on up to 750 cold cranking amps. As long as it's a 12 volt battery, you could use a 12 volt battery out of a 100 foot yacht with a standby marine diesel engine, as long as it's 12 volts with 6 cells with 2 volts each. But I may tell a lie. You can use the 24 volt battery as well. This switch and this outlet are both designed, and this wiring, all three of them are designed to handle up to 120 volts at 60 hertz and 15 amps. So got a lot of room to play with. If it handles that much, it can handle smaller loads. I don't know if there isn't any hertz rating for DC voltage. At least I hope there isn't. That makes it really complicated. But the DC voltage I want you to work with is 12 volts. 12 volts, and you can. I think I might even add a fuse to this 12 volt at 40 amps right here. In fact, I think that is in fact what I'm going to do. There you go. Look at that. 40 amp fuse right there. So I'll add that, and this will be the power side. So just in case. So this will be an added feature. Also, I'm going to add the ground wire to this, roll it up and zip tie it just in case. Added safety features just in case. Now, what happens if you ignite a rocket motor, but it doesn't ignite the motor, but the fuse still stays connected? Then all of a sudden, you catch the rocket on fire. Well, you hit the on-off button, but if that doesn't do the trick, then you also have this fuse, which will hopefully blow. But if that, I've tried to include some other safety features, but like I said, if you start getting if that electric match with the pyrogen at the end of it doesn't separate, break contact after you ignite it, and it sets the rocket on fire, but it doesn't ignite the motor, generally speaking, it will pop this fuse and break continuity of electricity going to that electric match. That hardly ever happens, but you just never know. If I feel like doing this, so that's exactly what I'm going to do. I got this kind of taken care of. I can put this and this like that. I turn these over like this. Got this there like that. I'm going to put this switch up here, and I'll put this switch down here. And what I'm going to do, is I'm going to run 2 black linked wires to both sides of the switch, so when it closes, this outlet will be connected to the outlet. When it opens up, you put it in the off position, this outlet will not be connected to that outlet. So how are we going to do that? I will show you right now. Let's strip this wire. I got a bunch of electrical connectors from Free Stuff, Craigslist Free Stuff. There you go, pull it like that. Pull the strand out with it, like that. Wrap that up, fold it in on itself like a U shape because of the size of these fork connectors, or spade connectors, or whatever you want to call them. So I do that, I crimp that down like that. And you know, the stuff I build has more than one use. So you can also use this for AC purposes to remote activate the remote on-off switch to activate an appliance if you think might be an explosion or shock hazard, or it may simply catch on fire and you don't want to be close to it. So watching this video, you can use it for that as well. However, this intention is to work with a DC battery for the purpose of controlling when you ignite the rocket's motor. I finally got around to watching the movie October Sky one more time. I was mistaken about the cast. Jake Gyllenhaal was the main character. Chris Cooper was backing up. Of course, the exquisite, lovely Laura Dern never ceases to amaze me. She was part of that movie as well. Jake Gyllenhaal really did a bang-up job with that. It was a lot more, it was a lot happier. The movie was a lot happier and more pleasant. I remember it being the first time I watched it. So sometimes you got to give things a second round to really appreciate them. But I enjoyed the movie all the same. We're going to cut this length about this long. Believe you me, we're going to trim the pant legs up. But let's just cut long and play it safe. Now somewhere we're going to put the fuse in line with the power and not the ground. So I think I already know what I'm going to do. Here we go. I gotta put it 16. Just measure it like that. Remember, you gotta fold this thing back in on itself, so give it enough length to double, you know, to fold. You fold it back in on itself. Anyway. Hold on. I think I goofed. I messed up. Hold on. Let's strip it one more time. Stuff is fairly forgiving. You can always execute a do-over. There you go. I do enjoy electrical. I like electrical design, but my heart is into rockets and aircraft. So there you go. Let's just get another one. I literally got a swollen kitty cat bag, a food bag full of this stuff. There you go. Keep it there like that. Grip it down as tight as you can. There you go. That is the other side. This is the negative side. This is the ground side that we're making contact with. That's kind of messed up. Because I don't want things to touch. Get that nice and tight. Check the tightness of both of these. Make sure that's tight. Alright. Tight. Tight is alright. Here we go. Cut that there like that. Now you gotta kind of plot out your moves, kind of like playing chess or building a Volkswagen engine, whichever you prefer. You've got to be careful what sequence you put stuff together in. Okay, so we're going to put these, we decided we're going to put these, we're going to put this outlet in here, we're going to put it in the bottom, but I'm thinking I am thinking, you know what, I think I'm going to do it the other way. I'm going to put this switch in here. You know, I like putting the button at the top bottom and orient to the flip top. I'll look at it like this. So, yeah, we're going to put it in this way. So we're going to run these two black wires through a hole in the bottom of this box. And this is the tricky part. This is where we're going to have to bend and run through the two holes, not just one. Let's see. Alright, I guess I'll just do one at a time. You have to stand it upright. Look in there. You kind of reach down there. A little bit more difficult than I thought it'd be. I have big hands. Small hands on this advantage. I have rather large hands, so this stuff is difficult for me to do. Alright, pull this baby through a pair of channel locks. There you go. Alright. You got it. Yeah, my hands are so large, I just... Okay, so there you go. So we're done with this switch. Oh. Actually, we're not done yet. I just forgot something. We're going to install the 40 amp fuse right here. I just want to protect the circuit. We'll use the same wiring harness we used before. This guy, we'll just cut it in half. I'll show you something that's kind of neat. You can turn any wire into a fuse holder. I'll show you how to do that right now. You don't need anything very large. What's this? Give the pliers. This is short. Grabbing space. Now watch what I do. And I'll show you why I'm doing it the way I am. I'm thinking maybe 40 amps is a little bit too much. Let me try something a little bit lower amperage rating. Basically the same thing. We're gonna prep that. There you go. Check its tightness. Now this is crazy, but and method. Oh no, none of this. I'm sorry. Wow, what am I doing? Crazy me. I don't know how effective it is to ground the circuit on the grounded side, or not grounded circuit. Excuse me, I'm going nuts. My brain's going one direction, my ear going another. I don't know how wise it is to fuse a circuit on the side of the ground. Honest to goodness, truth is, I haven't tried anything like that before. I'm not really up to date on electrical technique, how to say the actual physics of electrical engineering. More of an amateur electrical designer, a minor electrician. Nothing really special. I'm just going to get started. I just don't know. I was tempted to do that a couple times when I passed a point of no safe return on a project that I knew needed to be fused. By saying that, meaning I'd have to take apart and destroy a lot of stuff to install an inline fuse on the positive side on a DC project. AC projects are a little bit different. You don't use fuses. You use circuit breakers. That's another discussion for another time. But I was in a pickle because I had forgotten to install it. And I was thinking to myself, well, can I just go ahead and put an inline fuse? I'm going to try a 20 amp instead of a 40 because I think 40 is too much. And I was thinking, can I put an inline fuse on the negative side? And folks, I don't really think it's a good idea. Negative is basically the return side of DC electricity. And if it gets to the point where it pops, you install a fuse on the negative side of a DC power supply unit or DC power supply anything, tool, and it gets to the point where it pops a fuse on the negative wire, I'm kind of thinking that you're letting the problem that caused the fuse to pop exist for like 1 or 2 seconds longer than it needs to. That 1 or 2 seconds is critical because that can do a lot. The shorts to ground, DC or AC, the more seconds you give it, it exponentially will do much more damage. So it's important. AC electricity, those circuit breakers, wow, those things pop immediately. And one of the biggest killers of houses, cause of house fires, are electrical fires. They absolutely positively do not want anybody his house to burn down because of an electrical fire. Those breakers work very, very quickly. GFCI outlets work very quickly. GFCIs are ground fault connection interrupter. GFCI, ground fault connection interrupter. And you always see those outlets of ground sources of water. Oh, just blew out. So, but be careful. Electricity is not something to fool around with. Okay, so we got that. We got that. Now look at what I've got. On the positive side, why just by positive? guess what I've got? I've now got a 20 amp fuse to protect the circuit in case of a short to ground is going to generate more than 20 amps. Cause the wiring and the controller on fire. So fuses are to protect the circuit to protect a vehicle or a boat or aircraft from catching fire from bad electrical wiring. Same principle for houses, although again, the power, the ground, the neutral is a little different. I don't know which one is better than the other. Frankly, I'm a nice guy, I just prefer both. But anyway, here we go. So now I've installed an inline 20 amp fuse that's going to protect this circuit. Eventually, I'm going to have to amend this box the same way I am the independent power supply, the one that I built a week and a half ago, because I want to put a light and a piezo buzzer in it. I need funds for that. And then the other thing is, I'm thinking if I could find a way of maybe retrofitting where the switch is, putting an output switch, a gang on the end of this, and putting an output switch in it, because excuse me, technically, according to NAR and AAA, you're supposed to have a key interlock with a light or a buzzer, which is considered an arming, and then an arming switch, then a launch button. Okay, and the arming switch, the key interlock just gets power to the box. The arming switch, once you push that, it hits a light and or a buzzer. You got it armed. Then you hit the launch button. The arming switch is supposed to indicate there's continuity through the circuit. Well, they want to do that so that you know they're not going to have any false starts. At the end of the electric match, it's broken. This is all for model rocketry. So I'm either, in the next project, I'm either going to have to get a larger box, but I'm going to have to have the input-output outlet as per usual, but I'm going to have to put a lock in it, a key lock and tumbler in it, with two switches. One to arm the box after the key has been turned, and then another one to go ahead and serve as the launch button. I've got to keep my costs down, so I'm going to figure out how to do that. And then the other thing, I need a 10-foot lead for the input from the DC battery, and you need a 50-foot lead going from the output side of the launch controller to the rockets you're launching. Now 50 feet is the minimum. I have no idea what the regulations are for larger HPR model rockets, high-powered rocketry, level 2 certification, level 3 certification, experimental rocketry. I don't know what the rules are. You might want to look up AAA online. NAR, not so much. NAR is more into national education, educating little children. I shouldn't say little, I used to be one myself, and I like children. For school education for children, to try and find and harness that talent and get children involved in science fairs and math by engaging these rocketry products, or projects, excuse me. I'm talking back and forth. So, but AAA is more into experimental rocketry, high-powered rocketry, exotic kinds of rocketry. So you might want to contact them first and get the rules. I'm still going for my level 2 certification. But I've got to be honest with you, I just didn't like the appearance of my last level 2 rocket. And it's going to be a while. I need to get this settled. I need to get some more money rolling in. I already have 3 projects going. I'm going to get a 4th project started tonight, which I'm excited about, but we'll see how that goes as well. Okay, so we've got everything done for this outlet. We've got our inline fuse in. Curl it in just a little bit. It's going to interfere a little bit. Let's kind of set this in. Let's go ahead and set this outlet in. We've already got the a couple of screws and washers. I always recommend using washers with these screws, and the reason being is that when these screws turn, they tend to smash and tear up the material beneath it. With washers that are designed to absorb that kind of pressure, they prevent that from happening. So here's this, my glasses there, which I don't need, but I do. I'm done with this little outlet. Later on, though, like I said, we're gonna get a piezo buzzer, a light. We're gonna get the outlet. We're gonna get 2 switches and a key switch. We're gonna get a much larger project box, and we'll do something. We'll get the cables and cable ends, and alligator clips. Spend some money on it, and I'll show it to them. Look. Here it is. NARA-AAA compliant, launch your own rockets. We're not going to talk. I'm sorry about all the noise, folks. It's a particularly noisy part of Fullerton, and it is close to Saturday night. That's just how it goes. I want to make sure to get this done in front of you guys so that you can see how you need to do this for yourself. You know what I'm going to do about this? Nothing at all. I cut these wires. Now look at that, how they stick up like that. You kind of want slack on a wiring harness so that you can remove what it is you're working on that the wires are going to, and have enough slack to pull it out far enough so that you can work on it. A lot of people, when they wire things up, they wire the wiring too short and thinking that no one will ever have to remove it or service it, and that's just not true. Stuff breaks down and needs to be repaired. So here we go. So we're going to strip these wire ends. They're just long enough. I'm not going to zip tie anything because we're kind of going into overtime for the video here. I kind of get the sense that we're going a little bit long. So let's put the pliers here and pull that wire down. There we go. Wow, I thought this was a little tight. I felt that it pulled a couple strands out. It's okay. It's a DC box, so I'm not going to worry about that next time. Take your fingernail, fold it in the middle, down here. There you go. So disconnect these guys up like this, that on that side. Between Eaton, it's Eaton Electrical Products, which you can primarily obtain from Lowe's Hardware. Leviton you can get from Home Depot. I've got to be honest with you, I'm leaning towards Eaton. I think that Eaton and Eaton Fuller, they're an engineering manufacturer. They design products for automotive and electrical. I think they do a really good job. My personal opinion is to go with Eaton switches and whatnot. I just have better luck with them. Leviton is okay. It's better. It's just more easily able to manipulate, fabricate. It's tough to work on my work machine. What is today? Oh, today's Friday. Yeah, it's okay. Hang out for lunch. Okay. So we'll leave this up here. You know what? This is extra. Good. Zip tie that. No one to hold them. Okay, so I have one bolt and one washer. Kind of wondering where the other one went. That. About that. So go ahead and stuff this down there like that. I'll show you how this turns out as the final one is. Not like it gets one parts. That's okay. Go ahead and never mind, found him. Putting all these lines away. I'm just covered by a pile of electric connectors. Ah. Okay, so running these little screws in. I'm gonna push the switch over to the right. Just kind of like now we're done. Can't really show you how it works. I need a digital multimeter and I need an independent 12-volt DC battery so I can test and demonstrate this stuff as I'm shooting the video. So the question I have yet to ask is, what's wrong with you? There's more of this bird to ravage. That's what I'm going to do. So here it goes. It's all wired, ready, and set to go. This is one of those boxes where you could put the extension cord with the two-prong plug and the two alligator connectors connected to a battery. You can put it in this plug or in this plug. We can use a regular three-prong extension cord. Test a 2-wire AC powered component, and you can put the extension cord here or here. The output would be the opposite socket, and run that. This has to be down in the off position, and run that to the component that you need to check remotely. Sometimes when you rebuild something and you plug it in, you want to hit the switch. You're not sure if you installed the ball bearing backwards, or something's going to zap you, blow up, catch fire. It's going to shoot parts in your face. So why not test it remotely? The outlet, basically the input would be an extension cord. The output would be an extension cord, or the components safe link on the component's extension cord. The cord that goes into the component powers it up, connects it to the wall socket. So this is a remote switch. If you don't want to be anywhere near the component, you use this to remote text it. See? Products are well thought out well enough, they can serve more than one purpose with a smile on their face. Now, don't come to me and ask me plumbing questions, because I refuse to answer them. I'm a rocket designer. Anyway, this is it. My name is Jason Wampler. This has been another episode. It's actually episode part 2. The Rocket Minute. Again, I'm Jason, the host. Sorry, I'm going nuts. And I'm tired and it's hot. And I got to check in on my companion as to whether or not I qualify for another phone. Okay, we'll see you guys later. We're going to close that up. We're done with this project. For now. Come on, hold on. There you go. See you guys later.